and remove the vaccine. You can talk to them, can't you? Tell them all about it. Hi, Craig.
Hey, how are you?
I'm fine, thank you. How are you doing?
Oh, still shifting gears after the holiday season.
Oh, I was just about to email you, Sal, and then realised that you were there, and also it's still a bit early. So, we've been chasing our dog around the village. Well, trying to find her. She escaped under the gate. Stupid animal. Luckily, someone cornered her, but she's very, very clingy now, aren't you, Myrtle, darling? I just want to lie and be sad, but she's fine.
I have a lot of trouble thinking it's hard to catch that dog when it runs, but I'll believe it.
Well, we were surprised, but someone came to our door saying she's escaped, and then we had to find her. So someone had cornered her by the time.
Oh.
Anyway, it's all good fun. Not what I needed, frankly, but there we go. Bit of exercise, I suppose, is good.
I just read an article this morning. It was talking about how some of the historical stories about different dogs that have traveled far distances to get back to their owners. Thousands of miles. So
yeah, getting back is fine. It's escaping in the first place. Anyway.
Well, I was just going to posit, if you chilled and just had a cup of tea or something or coffee, and if you waited an hour,
we live near a couple of roads which can get quite busy, and particularly that time of day, we just couldn't risk it.
Looks like he's trying to bust loose again, he or she.
I think that my wife and daughter are back. Yes, they are. And the gate's closed. Okay, she got out underneath the gate, however. So apparently so. Yeah. So that's what Vic says. I'm on a call, so I'll leave you guys to it. Okay. Right. She's under supervision. So
excellent. All is well in the world again.
Yeah, well, the problem is I need to be under supervision most of the time, according to my wife. So that's fair enough. Can't be trusted. Think myself. Sal, have you had a major haircut?
No, I just had my hair up.
Oh, okay, fine. I can say I had a haircut today, as you can probably not tell.
Yeah. But I did just get off a really cool call with Verizon, and there's some cool other meetings that we should be in touch about. But today is about solution.
It is. Who tends to lead this?
Well, I'm the chair today. This is Jim Beanie.
Hi, Jim.
So
it's been a while since I've come along. So I thought I'd come along, partly to introduce Sal, who doesn't really need my introduction, but also just to catch up and see what we're up to.
Sure. Yeah, it's been a few weeks now since we met due to the New Year and the holidays. But yeah, I think our last meeting was almost a month ago. Oh, more than a month ago.
Remind me again who Sir Mix-a-Lot is.
Sorry, this is Keith Moyer
from
Google.
Apologies. Thank you.
Yep. One of the co-chairs.
Yeah, it has been a while. Sorry.
No worries.
But we should be getting a very cool demo today, and I'm excited.
Back in the day, I was in a startup, and we moved to some new offices, and we had to choose some names for the meeting rooms. And we chose things like hiding and vain and desperation. So we're meeting in vain. We're meeting in desperation. Meeting, which is great. I have to say that was a really nice theme.
These people are still joining, but we did have a few topics to go over. That Ned did present his co-rem attestation results last meeting, and he is here today. That we could finish that up. I know that he's on vacation today, so maybe Ned, if you wanted to go first on that, so that you can decide to drop. And also, Sam is prepared to discuss the Linux ABI attestation. I think those would be the two big topics today. Anything else?
Yeah, hello, Sama here. So I wanted to have a couple of minutes for a couple of announcements. So if that is fine, maybe at the start or at the end, wherever it fits, if we have time.
Okay. Yeah. How about after Ned?
Sure, thanks.
Yep.
Ned has the unfortunate task of refreshing our memory as to what the heck we discussed before the long holiday season.
I was going to say, I think we got to the end of the presentation and we were just wanted some time for Q&A. So, but let me rewind a little bit. So we had a slide where we said, hey, guess what? This is what the ending state looks like in your verifier. After which the verifier is going to do some analysis, apply some policies and whatnot, and potentially come up with some new claims that are maybe an abstraction of the detailed set of claims or are the subset of claims that are important to the relying party. And those claims can be asserted by the verifier in a way that's sort of aligned with the approach that, say, the co-rem schema uses to keep track of claims. And there's some examples here of AR4SI style of claims that the verifier could assert, under its authority. And then we said, oh, and this is what it looks like in, the accepted claim set or the final state representation. There's a whole bunch of stuff here. And then we had a conversation about, why might that approach be important? And we said, well, there's actually a variety of different use cases that apply to verifiers, which are facilitated by sort of this common kind of internal representation of claims beyond the relying party's expected view of that data, right? So if you refer to use a database terminology, we would say that the verifier is maintained in a database of claims and different relying parties want to define views on that database. Okay. And then we talked about these use cases where, it's nice to have a common oracle, which is what I just said. ACS is the database and the various schemas to the right are like views on the database. And then we had the use case of a verifier mesh where, maybe you have multiple verifiers that are cooperating in some interesting way, and they need to pass partial results around and where each contributes something to the overall picture. But then there's sort of one verifier that finalizes the database, if you will, and then applies the appropriate attestation result function to present the view that is appropriate for the relying party. And then just in general, having the ability to apply some consistent correctness tools to the database, it helps to have a really consistent model for how you represent claims. And then we transition to this comparison between ear and car. Ear is a draft. It has not been adopted by RATs yet, but it's comparing what the differences are and the similarities. And the short answer is they're really similar. The main difference is that ear is in some sense, it's like a view of the data set, whereas CAR is saying, let's just reuse the CORIM schema to represent the things that the value add that verifiers bring. We can just reuse CAR for that.
So is this a proposal for the internal data structure of a verifier that then makes it easier to support different renderings and different token types, or to between verifiers, collaborate, perhaps more seamlessly versus like slinging around one slings CWT, one slings JWT, and having them wrestle with those translations? Or
So I wouldn't go so far as to say that it's a internal representation of the data set. So there's, there's still, every verifier is going to have an internal representation, which is, outside the scope of the standard, but it's trying to say that the CORIM schema is flexible enough that it can be used to provide a consistent representation of the semantics of the data.
so
Whether-
if you go back one slide to where you had like that one there in
Yeah.
the top left corner, the way that one reads to me is on the right-hand side are the schemas that relying parties see. And the purple rounded rect on the left is something else. So you just told me it's not the internal schema, and yet it's not what relying parties see. So what is it?
So
Who-
so maybe just be clear to clarify, in the CORIM draft, it uses the term internal representation to refer to an implementation specific representation of the data. Okay. What ACS is describing is a representation of the schema as opposed to a representation of the implementation, right? And it's sort of, maybe it's a subtle difference, but the main point is that the boxes to the right are lossy relative to what's contained in the ACS.
Mhm.
And so we want to try to standardize around a non-lossy representation of the claims, and then apply the appropriate, view of that data, which is lossy. It's necessarily lossy, right?
So if to try to make this concrete for me, so let's just say, Microsoft has a verification service that I work on, MAA, and we have our internal format for how we, deal with all of these data structures while we're doing the verification. And then we have, what we support at this point, which is JWT for the token type, which is what relying parties see. So how would the ideas in what you're discussing here, affect and influence what we do in MAA over the upcoming months and years?
So I think maybe this slide might be a little bit helpful, right? So let's say that for the JWT representation, you care about, I don't know, the AR4SI trust tier, and you care about one of these other measurements. Let's say you care about, this thing called advisory off to the right, the CVE6 advisory information. Let's say you care about those two bits of information, right? So the schema for the JSON representation has those two values in it, and all the other ones it throws away because it doesn't care.
So let's just say that, that schema already exists, right? The relying party is interested in AR4SI and in the advisory. We've somehow put that into our JWT schema, perhaps not aligning with an EAR standard, for example, but we have a JWT schema for that, perhaps using proprietary claim names. So
Right.
how does this work here influence that schema, which is, I think, what I just heard?
Yeah, so this is saying, hey, the CORIM schema is sufficiently robust to be able to represent all of that information already. We should just reuse it.
So you're saying, I think what you're saying is that the schema in these different manifestations, CWT, CBOR kind of stuff, or JWT, JSON, the structure can look more like, if I look in more detail at the ACS structure here, can look more like that versus like what we have now, which is very simple, like, you know, string for a key and string for a value, typically in a JWT JSON claim set.
Right.
So it sounds, so from my perspective, I think what we've done or have attempted to do is we've been attempted to be relying party centric and make the results in a token as simple as possible for them. So if they think of something like AR4SI, you know, it may, you know, we try to make the different concepts there simple, top level claims. If it has a concept of foo, then it's in there with the claim name foo, and whatever the most simple data type is, a Boolean or a numeric value, it appears, you know, next to that foo claim name.
Right.
So this seems like, at best, it's keeping things from a relying party perspective. At best, it's keeping things similarly simple, but perhaps different names. Or at worst, it's complicating things to get to the same concepts that were accessed more similarly in the past.
Yeah. So, I mean, to the latter, I would say the complexity is already there in the verifier, whether you realize it or not.
But we're talking about I'm talking about the relying party. So that the philosophy in MAA that we try is try to make, you know, one of our purposes in life is to try to make life as simple as possible for the relying party.
Sure.
And we've done our best to, like, you know, adjust our schema so that it's as kind of one-to-one with the concepts that they are trying to use.
Yeah. So the RATS architecture has a diagram that is referred to as the bow tie diagram, but I don't think we name it that. If you search for bow tie, I don't think you find it, but it's towards the bottom. And it basically shows a bunch of different formats to the left of the verifier, and then a bunch of different formats to the right of the verifier. And the assertion is that the verifier has to deal with this complexity. And the complexity is both in terms of formatting differences as well as schema differences. And, but then there's also another draft which is making its way, which was authored originally by Dave Thaler, which is to say, hey, if the true complexity of the bow tie were realized in practice, it would be, you know, death by 1,000 cuts. We really need to focus on a small set of, you know, formats and schemas, ideally one, but obviously we're never going to get to one format. But if there's a schema that satisfies, you know, both sides of the bow tie diagram, that makes a really good choice for representing the data. And
I think in my head, there's the logical schema and then the physical schema. So logically, you might think of, you know, like AR4SI has logically some, you know, name value pairs or name value vectors, what have you. And then there's the rendering in JSON and CBOR and X509 extensions and so on. And those have the nuances of, you know, those particular rendering formats. But what I think I'm hearing is I'm not let's say, for example, in my mind, there's that, let's say, for example, ear, if it's tied to CBOR JSON at the moment, I am, or like AR4SI, right? That's the logical schema. And so then if you take that to JSON or if you take that to CBOR, there'll be some, you know, there's the details of what that means. And hopefully, you know, the concepts for the logical schema are directly kind of an obviously, it's direct and obvious how to express those in CBOR and JSON, for example. And so in my mind, you know, we're already at this mode where there's a logical schema and it should be as simple as possible for the relying parties, kind of tuned to the relying party, because they're the consumers of the verification results. So I think it totally makes sense to me that we kind of logically we have one way to look at things, AR4SI, and or what have you, and there are different physical renderings in different physical formats. And perhaps if we discover that those physical formats cause that, make it so that they look very different, they can't be made to look similarly, then that seems like problems to investigate and figure out kind of an overarching philosophy for how to approach that. I'm not aware that that's the case.
So, I mean, I think we're largely saying the same thing.
Okay.
If we look at, so this slide is showing sort of a hand wavy internal representation of the ACS. So the ACS is an internal representation of the data. And, this is just, key value pairs is, at a high level, it's just key value pairs. But there is, you can see the structure of the, the environment measurement tuple, the EMT. That's a construct. That's a co-mid schema construct, which is which is a higher level representation of the data beyond just key value pairs. It's like there's
and are you suggesting that gets exposed to relying parties when they're perhaps interested, just their mindset is AR4SI? Or
what I'm saying is, I can take an AR4SI concept, which is like the trust tier or the trust vector, and I can realize it as a measurement in OMID schema. It's just another measurement type.
Got it.
Okay. So I don't have to reinvent kind of the rest of the context around, the EMT structure or whatever semantics are wound up inside of a triple. I can just reuse it. It's just a measurement type. And that's primarily what a lot of the specs are doing, like EAT and so forth, AR4SI. They're just saying, here's a measurement type that we think is useful. But COMID is saying, yeah, there's more to it than that. There's also some compositional logic. There's some semantics about how these things relate to one another. And it's more of a schema like you would think a database schema, right? It's a little higher level than just, data, a data item in a database. It's a database of a schema that, there's multiple parts to it and they relate to one another.
Yeah. I think the biggest disconnect in my mind is, or the biggest question in my mind, which I'm not clear on, is there a need or a value or benefit to exposing, is the model for relying parties better represented as encompassed in CORIM and its concepts? Or is it better for the relying parties in, I call it simpler, but we can forget that term, in the claim set paradigm that's basically proposed by EAT, right? And which an accepted a standard at this point. So that because EAT is just a bag of claim. It's just it's a claim set, right? Bunch of name value pairs.
It's a list of name value pairs.
Yeah, and it's intended to be, as I understand it, to represent, what's consumed by relying parties is one of the use cases.
Right. So we caveated EAT with you can't implement an EAT without also having a profile of EAT.
Yes.
So then that introduces some ambiguity of, well, how do you manage profiles of things and have interoperability? Because now it's sort of the door is open for a lot of people to do things differently. So you need another specification that essentially defines the profile of EAT. And that's exactly
like for example, isn't that what EAR does, right?
Yeah, EAR is doing a profile of EAT.
Yeah, and it has nothing to do with CORIM at the moment, I believe.
Right. And so what this presentation is trying to observe is that you can get the same semantics that are in this profile of EAT for attestation results by reusing the CORIM schema, the COMID schema.
Yeah.
And
And I guess I'm struggling with that. There's an infinite number of things I can do,
yeah,
but what are the subset of things that, have value in doing? I get that we can do this, but what's the motivation? Who's it benefiting? What's the spark that, causes some of these things to be done? And that's what I'm still trying to wrap my head around.
well, I mean, that's kind of what slide 15 is trying to motivate. It's like, okay, well, it's an oracle then, right? I can use it as an oracle. If I don't have this oracle, then I have, multiple different sort of fragments of what you might call an ACS, and, maybe ACS1 can do some of the bow tie to the right, and the other ACS does some of the bow tie to the right. Right? It's just not, it's fragmented, and it's, you don't, it's like, I mean, yeah, you could cobble all this stuff together and it could be hidden under some implementation somewhere, but it just adds complexity, right? It just it creates friction for broad implementation of this kind of capability. And it's not, I'm not saying, yeah, you can't do it. I'm just saying there's a better way to do it. And our standards ought to not create friction. They ought to remove friction. That's all I'm advocating for.
All right, makes sense. I've said a lot, so I'm going to be quiet now and give others a chance to ask questions if they have. Thank you, Ned. That was very enlightening.
Mhm.
I was following along quietly here because I think Jim's comments were lining up with everything I was about to raise my hand for. My instinct is to also kind of resist anything that pushes any amount of complexity to the relying party. And like one of the major values of the verifier is that it does encapsulate a lot of that. I think what you're saying is, I think it has some implication of maybe exposing some of this out to the relying party, but I'm still not quite clear on whether that is necessarily the case, or is something that from your point of view should still be avoided, or is unavoidable. Like you were saying, the complexity exists anyway, but I think placing it in the verifier is appropriate. And I'm still trying to place what your proposal is positioned.
So what I'm saying, so if I were to try, if my goal was to build a verifier mesh, take the second use case on this slide, and my only tools was I had the ear draft, or the ear spec to work from, then it's going to be harder for me to implement the mesh. I could probably still do it, but it's going to be more difficult because I have to transition away from the COMID schema to the ear schema, then back to the COMID schema, right? So if the standards allow for a COMID representation of the data, then it makes it much easier. There's less friction to implementing the mesh use case.
Okay, so is it
So
adding one additional output format for a verifier that is more convenient for consumption by other verifiers, but then for end relying parties there would be no change?
Basically, I was just saying, hey, I can take, there's some new things that ear does, that if I were to just describe them as extensions to measurement values map, then I'm done.
Okay, I see. Thank you.
Sorry, there's another option, right? So that you can have the requester to ask the verifier to output in one format or the other, right, through the API. So say here, if I'm a relying party that wants to use Rego to verify the CWT in one go, or give me the dump using car if I'm another verifier that is going to take care of, say, another
Yeah.
bit of verification, right? So for example, in CCA, we have two-stage verification, one for the platform, one for the realm, one from the workload. So you could have the workload verifier ask the platform verifier for a car, and then consume that and produce the final year for the real Reliant party. That might be one option as well.
Yeah, I think that the necessity for the requester to be able to tailor what output they're getting is, I think, one of the big values of the attestation verifier, because it allows the relying parties to be focused on their use case, which not all use cases can be kind of shoehorned into the exact same type of representation. Some of them have use case specific needs. And I think having it be X509 or EAT or some commit based schema, I think is desirable, not to be avoided. But I need to drop early. This has been a great conversation.
Yeah, I need to drop as well.
Okay, thanks. Yeah, the time check was 30 minutes in, so I appreciate that. Ned.
Okay,
Thank you, Ned.
all right, talk to
Thanks,
you later.
Ned.
Okay, next topic, Osama, do you want to bring up your reports?
Oops. Oh, sure. Thanks a lot. So yeah, a couple of things. First, I wanted to congratulate the SIG as well as thank the SIG for the feedback on our work, the project on the formal verification of attestation mechanisms. So we have got it published at IEEE Access, which is a very prestigious journal with an impact factor of 3.9, which is very great. I mean, normally we have in the journals like 0.7, 0.8, something like that. So I really wanted to thank all the SIG, especially Thomas, Simon, and Shale. They have been contributing to the whole of the work as well, including the writing and a lot of things and feedback as well. So thanks a lot and congratulations to the SIG. We have another work on the second project, which is the attested TLS, which is now under submission. So hopefully we will have another great news. The second thing quickly I just wanted to mention was we are organizing an event in which both of the projects that I just mentioned, most of the members of the both projects are participating, and other members of the SIG are also very welcome to join that. We have it in 27th to 28th March in Dresden. And if someone of you is from Europe, we can hopefully cover your cost as well. If you are interested, please contact me. And if you are outside Europe, the regulations are quite strict on that because it's a European network of researchers and so on. So, but hopefully CCC might also be able to sponsor you for that if you present some of your projects or some of your works. So yeah, these were two quick announcements that I wanted to make. Thank you. Thanks a lot.
Thank you, Zama, for all the energy for driving this work to completion very, very quickly. In fact, thanks a lot. It was a very interesting experience for me.
Could we have a reference to the journal if there's any online thing that we can hype up and mention on the website and all those sorts of things? That would be great. Well done.
Yeah, thanks. Yeah, I will put it in the notes so you can then reference it.
Cool. Sally, happy to take that.
It's already in the notes there.
Okay, great.
Thanks a lot, Osama.
But I do agree, exciting. And there's one last thing, and I think you might actually know the day for it, but what day is the Diffie-Hellman online interview? Do you happen to remember? It's a side note, but I think this crowd might be interested.
So are you mentioning about the seminar, which is I think at Edinburgh University or something like that?
Yeah,
In
but
the
it's
UK?
on.
Yeah. I think so. I have to dig out the date when exactly is it? So
Sure.
yeah, we'll put it in the notes as well. Yeah.
I'll add it in the notes. I just think that this crowd would be interested. It is one side of the Diffie-Hellman actually talking about it. Worth your time.
Yeah, sure.
All right, thanks, Osama.
And one quick, so sorry, one quick thing from one final 130 seconds, please. So if someone from Intel can present, so for the third project, I wanted to ask if someone is available. I contacted a couple of people, Mona and also one other person, but they didn't manage to, Dimitri as well. So I think 3 or 4 of them, so they couldn't manage to be available. So if someone is available from Intel, Dan or you, if you can contact them, that would be very nice.
For the March event?
Yeah, for the March event, that would be for interested. So that we have a complete presentation of all the 3 projects. It would be nice, even if you don't find anyone, let's say, because I know Shanwai is no longer in Intel now, he has retired, but let's say if someone can just present Intel TDX or somehow represent the third project partly, it would be great. Attestation. So formal verification is just another stream, so that's not a requirement. So you can present in, let's say, attestation or confidential computing stream. So that's completely independent of formal methods. So that would be really nice.
Okay. Yeah, I think Dimitri would be the best bet for that. So I'll see if I can follow up with him. And did you have somebody? I think you mentioned. I'll just DM you with it.
Okay, sure. Thanks.
Yeah, thanks for that. Okay, next topic, Sam, if you want to take maybe the rest of the time, not sure how long you need on the ABI, Linux ABI for attestation.
Hey, yeah, I'm not sure how long how long this is gonna take, but I put together a few slides for this.
Okay,
Let me share my screen. I think you'd be able to see something relevant to that discussion.
Yeah, I can see.
Okay, cool. So I'm going to talk about the kernel attestation ABI work that's been done recently, and just a quick note. I've participated to the conversation on this ABI and this work that's happened upstream, but this is not me implementing this thing and driving the whole patch set. It's Dan Williams, the other Dan from Intel, that's been working on this with the participation of a bunch of people from many companies. So it's now upstream. So if you take the latest Linux kernel version, you will find this ABI implemented and available. So this is why I think it makes sense to talk about this here, because, well, if you're running on a confidential computing guest, this is the attestation ABI that you're going to be looking at. And yeah, if you have any questions, please feel free to interrupt. Hopefully this can be interactive. So some context, what do we mean by a kernel attestation ABI? It's a user space kernel interface, a Linux kernel interface. And right now what it does is allow, it provides a way for application to generate attestation reports when they run on top of a confidential computing architecture. So yeah, just to be very clear, this is an ABI that's only accessible from Linux TVM guests. So that conversation is basically relevant only for confidential computing architecture that support full VM guests like TDX, SEV, CCA, or Cove. So those are the ones that I know about that you can run basically a full Linux TVM guest on top of a confidential computing architecture. The use cases, there are many of them. The one that I'm particularly interested in is the confidential containers use case. Confidential containers as in the confidential containers project from the Linux Foundation that uses encrypted images or that relies on attestation for retrieving secrets. And this is basically one consumer for this ABI. And as a matter of fact, someone from Intel, Mikko Ylinen, just landed a PR for supporting this new kernel attestation ABI from the confidential containers implementation. VM encrypted disk images as well, where you basically get a encryption key from your initRD, and then can decrypt your disk image in order to boot into it. Attested TLS, attested SSH connections, and many more use cases. Basically, any use cases where you need to attest to your workload or your Linux TCP from an application would be a consumer for this API. So this is the context, the use cases. I think we all agree this is useful, and there's definitely a lot of needs for having this API. But what is the problem? The problem before Dan Williams started to look at this new proposal is that each and every architecture would provide its own API. So if you're running on top of SEV, you would have a character device under /dev/SEV guest, and if you'd be running on top of a TDX, you would have a different character device to which you need to talk to as an application in order to get that attestation reports. Not only you need to talk to a different character device, but well, first of all, all of those were ioctl based, which is not very convenient of an ABI. But most importantly, all of them used a diverging set of commands and replies for talking through this character device. So different commands, different replies, depending on the architecture you will be running on top of. Basically, as a use space application, you'd had to know which underlying TSM or architecture, computational computing architecture you're running on top of, and then implement a different ABI for each and every one of those architecture that you want to support. So we had this problem in the computational containers project, where we run on top of TDX, SCV, CCA, and IBM's implementation as well. And basically, we have to scan and dynamically discover which computational computing architecture is available, then switch to the dynamic ABI in order to basically simply get an attestation report. So not very scalable, not very practical, quite difficult to implement. And for each and every new architecture out there, you will need to basically extend your user space application for each and every application, and each and every user space framework that would like to get an attestation report. It basically would need to follow the new implementation coming in the kernel. So the solution that Dan proposed, and that again is now merged in the upstream Linux kernel, is a configfs ABI. Now with this approach, user space sees only one single interface across all architectures. Not only one single interface, it's a configfs interface, but the complete ABI is completely, the whole ABI is completely architecture agnostic. Each architecture becomes a TSM provider for this ABI. And basically, if you look at how this is internally implemented, each and every architecture, by architecture I mean TDX or SEV, which are the two implementers of this ABI right now. They have to implement and register a TSM ops C structure against the TSM framework. So configfs is the user space ABI for this. There's now a TSM framework against which each and every architecture that wants to be exposed to user space for attestation report generation needs to register against. Configfs, some of you may be more familiar with SysFS, which is pseudo file system for Linux for basically configuring a system or platform. configfs is more suitable for what we're trying to do with this ABI. The initial proposal was actually on CCFS, and then Dan realized that there were use cases where multiple applications would want to have their own instance of the attestation report generation. And CCFS is really not designed for this. So basically with configfs, you'd be able to create one report generation instance and basically bi-mount one such instance per container if you want to get an attestation report per container or per application. Doesn't really matter, but with configfs you basically can do that, and it's much more difficult to do it with CCFS. To be more practical and concrete, this is a very high-level view of how this interface could be used. Assuming you have a configfs mounted under sys kernel config, if your platform, if your machine supports a computational computing architecture that is registered against the TSM framework, you're going to get a sys kernel config TSM, a TSM folder on which you basically create an instance of a report generation. So to do that with configfs, you basically have to create a directory under this hierarchy, and by creating a directory, by creating the sys kernel config report/report 0, you get an instance, a handle to which you can talk to in order to get attestation reports out of your architecture. So once you created this report, you can pass it a nonce to get a fresh attestation report. And once you do that by reading the outblob binary attribute out of this configfs entry, the report 0 configfs entry, you basically get your attestation report in binary format. There are a few more attributes to this that you can configure, but basically that's the idea. You create attestation report generation instance, and then you pass it your nonce, and you can get multiple and as frequent as you want or as scalable as you want attestation report instances by basically reading your outblob attribute back. So this is completely architecture agnostic. If I'm a container or initRD application that's responsible for decrypting a disk image, I just need to do this independently of which confidential computing architecture I'm running on top of, which is a very welcome improvement over the existing one before that got into Linux. Greg, you had a question?
Yeah. One of the common scenarios when generating an attestation report is to provide a value for what's called report data in, I think, both TDX and SevSMP quotes and reports. And so I assume that's one of the values it's possible to send through this mechanism that you just kind of said other attribute. Okay. So there's a standard way to do that. And
that's what you pass as through the in-blob attribute. So the in-blob is a write-only attribute. You basically pass this through that.
What about things like I believe like I'm thinking SGX, and maybe TDX has the same thing, I'm not sure, but SGX has like ways of controlling the actual quote format, whether things like the backing X509 chain tracking back to Intel are included in the quote and things like that. Is that also possible to control in?
So again, this specific interface that doesn't, SGX doesn't implement it at the moment, but TDX and ACV already have different reporting attributes. So on SCV, for example, you can, as part of your attestation report, you can get a certificate chain, and basically, yes, this is something you can define by configuring the type of provider that you want that you're talking to, and depending on this, you will get different attestation report attributes, IV or outblob file. So yes, this is something that's already taken into account.
All right,
But
so
it's
this is
not through the
stateful,
API.
right? And that's why we have these different instances for every consumer, I think is what I understand.
Correct.
So is it you set a bunch of state and then when you want the actual report, you refer to /outblob?
Correct. And
Okay.
there's a mechanism for basically if you have multiple and concurrent requests for getting attestation reports, you have a counter in this an in-block counter basically to check if the attestation report that you get is basically the one that maps the in-blob value that you just passed. So if
Okay,
multiple
got it.
applications pass different in-blobs, you can when you get the out-blob back, you can actually verify that that is the one that corresponds to the in-blob that you passed. So
Right, cool.
there's only
My
one
hands
TSM,
down.
obviously, but potentially multiple consumer of these reports with different report data. So you may have to request multiple times your outblob until you actually get the one that corresponds to your in-blob.
All right, my hands down, there's more hands up.
Is the in-blob like a user data, or there is separate interface to pass the user data when you get the attestation report?
So the in-blob is basically a generic name for, as Greg was saying, what TDX and SCV call the report data, which is typically user data plus some nonce for freshness, or maybe only a nonce. But it's anything that you want to pass and be part of your attestation report as a report data.
Okay. And one more question I had was, if tomorrow new architecture is introduced, how much effort it will be to integrate with this system?
How much? Sorry, how much? Again?
How much effort, or how much kind of lines of code, or in terms of effort?
I can point you to the amount of code that TDX and SCV had to put there to implement this, but it's
okay.
It's really not significant. SCV, and it's not really different compared to, for example, what CDX wanted to do, or the TDX maintainers wanted to do to basically get the attestation report through their initial approach, which was a character device. The accommodating to this specific API is not. It's not going to make implementation. It's not going to add some more implementation work to architecture compared to what they would do with a raw character device, basically.
Okay. And one last question is, when the report is out, it is the format of the report is very much the technology specific, right?
Yes,
so
correct.
Okay, it's not a generic format. You are not mapping the claims to another JSON format or anything.
No, no, no. It's what you get from outblob is your architecture specific attestation report. Okay. So the kernel does not translate the architecture specific bits into a generic EAT or ER payload, basically.
Okay, thank you. I'll pass on. Thomas has hands up as well.
Yes, thanks, Sam. This is also awesome. And a question about the size of this user data plus nonce thing.
Yeah.
Is it how much?
I think it's still 64 bytes, Thomas. I think I remember you mentioned the fact that some architectures will be needing more than this. Mm-hmm. But I think it's still 64 bytes, and I honestly, and keep in mind that this ABI is on Linux. On the Linux kernel, you have multiple different levels of maturity for your ABI, and this is a testing ABI. So it's not something that's written in stone. So you can definitely, if architecture come with a need for larger in-blob size, that I don't see a problem for doing this.
I mean,
And
CCC.
if I could just-
Sorry.
Let me just interject real quick, because I think that even at Intel, we might want to boost from what we originally put in. And we have this kernel sig that we're going to be spinning up with the CCC. So that might be like a nifty point of collaboration where we can get organized there.
Yeah. Thanks, then. And yeah, for ARM-CCA, this is not going to be a problem right now because we have nonce. We don't have user data. We have a nonce, and nonce is 64 bytes, so it's perfect. But yeah. And by the way, an ARM-CCA implementation of this is gonna come up soon.
Cool. Muhammad, I think you have a
Yeah, so just a follow-up on Thomas. So is it really a problem that 64 bytes? Why cannot we if there are more bytes, so we can just use the hash and put into the R data, right? Like if there is more material that you just want to pass on inside this field, so you can just hash it and just pass this hash and send the other around. So I'm trying to understand why 64 bytes is not sufficient.
If an architecture requires more than 64 bytes, then you will need to, from the common implementation of this ABI, you will need to basically accept this and basically allow for more than 64 bytes to be passed through in blob. I guess this is the only limitation.
Okay, right. Thanks.
All right. I think I just have one more slide. Yeah.
Just
next step.
Sorry, just one more question.
Go ahead, Jim.
And I think maybe Greg touched on this a bit. But if an architecture, single architecture, supports multiple format types of out blobs, how can you indicate on the in blob which one to generate?
Let me.
I mean, is it possible to have two report types supported on a single architecture?
I think this was discussed, but this is a read only. So the out blob is read only, and right now it's not possible, but it's as part of the basically you can map your aux blob format to the provider attribute in the config.fs. To answer your question, there is currently no way to, if an architecture provides multiple support for multiple formats, there is currently no way to specify which one of those you want to get out of aux blob.
Yeah, because I know that TDX is going to be moving into this direction where the format does change based on the root of trust supported on that platform.
Mm-hmm.
And we also have the idea of legacy. So certain verifiers may only support certain versions of that out blob, and that the verifier may have to report to the attester which format to generate.
Yes. So yeah, this is that makes sense, and I think this is something that could be added to this interface for this specific case, which right now at the when this initial architecture was merged, it was not existing. So yeah, I don't think this would be a major problem for, but it will also be dependent on the generation count. So basically, depending on which format you want to get out of aux blob and your nonce, you would get one specific attestation report binary payload, and as a requester, as a verifier, you would have to check on the generation count that to basically verify that the payload that you get actually maps your configuration, that no other application actually changed this before you requested for before you read the outbuild back. So I don't to answer your question in a more direct way, I don't think this is going to be a problem if you want to extend this ABI to support these kind of use cases. But right now it does not support it.
Great, thanks.
Okay, we only have 1 minute left, and I just really briefly talk about the next steps, and you know, don't take that as a formal roadmap or anything. It's basically just something that we discussed at the Plumbers Conference or over email or during some specific meetings. But basically, runtime measurement registers is something that we want to add as a support for this TSM ABI, and maybe in the longer term also being able to get device attestation report out of this out of the same ABI for each and every device that's bound to a specific TSM. And that is all I have. I hope this was somehow useful, and I think this is going to be quite impactful for all Linux applications, as I said. So maybe have a follow-up discussion on this. Maybe also keep people updated on the evolution of these interfaces in the future.
Hey, thanks, Sam.
Okay, that's all I have. So, and I think we're at the top of the hour.
So yeah, usually the last thing we do here is select the next chair.
Say again?
Meeting. The next chairman for the meeting, next meeting. I think it's typically one of the
Jim, I can take it.
current 4 chairs. It's Thomas.
Yep.
All right, thanks.
Yes.
All right.
Thanks, Thomas. Thanks,
everyone.
everybody.
Yep.
Have a great couple weeks.
Thanks, everyone.
Thank you.
Thank you, Sam.
Thank you. Bye.
Bye.